Hello everyone, today I'm going to be presenting the Purpald test. It's a very interesting reaction that has to do with aldehydes and ketones. However, before we start, I want you to note that the solutions and reagent colors in the upcoming slides are not the real colors of the reagents. They're simply there to help you with identifying and assigning each step to an added reagent or solvent. In your first step, you will be making what's called a phase transfer catalysis, or PTC solution for short. It is a way to facilitate the migration of the reactant from one phase to another, essentially synthesizing new organic compounds. It can only be used, however, when your solution is heterogeneous, as in your solvents are immiscible, hence the term one phase to another. In this experiment, your PTC solution will consist of dissolving 1 gram of tri-N-caprylyl methyl ammonium chloride in 10 milliliters of toluene. In this slide, you will see how to prepare the Purpald test. Additionally, I will show you the preparation of both positive and negative controls. Now, the Purpald compound is present at the bottom left of the slide, as you can see. It is a colorless reagent and it should be present on your reagents shelves at the back of the lab. If not, please ask your lab TA to give you the reagent. Firstly, you should measure 10 milligrams of Purpald on a scale and place it in 2 different test tubes. Then, add 10 drops of the PTC solution you've just prepared to both of these test tubes, followed by 1 milliliter of toluene. After doing that, you should add 2 drops of your solution containing an aldehyde to only one of these test tubes. Now this will be your positive control, followed by 10 drops of 10% NaOH to both test tubes. This should give you 2 different test tube constituents, one containing aldehyde, which is your positive control, and the other not containing any, which should be your negative control. The diagram at the bottom right of the screen should illustrate all of the steps mentioned just now. So, the reaction mechanism of Purpald with aldehyde is as follows. The triazole condenses with an aldehyde to form an unstable oxygen labile intermediate, which is inactive in the presence of oxygen. Then, the oxidation of this intermediate leads to the formation of a purple, intensely colored, bicyclic, heterocyclic compound. After preparing your solution as seen in the previous slide, you should seal it with a stopper and shake it. After shaking and removing the stopper, your positive control should turn into a purple colored solution, whereas your negative control should turn into a yellow colored solution. However, if no color change occurs, heat your test tube in a hot water bath at 70 degrees Celsius for 2 minutes. Examples of positive controls are benzaldehyde and butanol, whereas examples of negative controls are diethyl ether and acetone. It is important to note that some false positives may take place for compounds such as dioxane, 1,4-butanediol, and diethylamine. Finally, the cleanup process is relatively easy. You just need to add your solutions into a separatory funnel and perform extraction as usual. You add the best extraction reagent to each organic compound, you shake, you vent, and you collect it. Repeat this process 2 to 3 times to ensure most of the compound has been extracted, and then separate the organic layers into organic solvent containers and the aqueous layers into aqueous solution containers. This is it for the Purpald experiment. Thank you for listening.